Good morning, Year 10. I hope you had a nice weekend. I'm sorry I can't be with you this morning, but please pay attention and hopefully we can get through these things. So we're looking at volume of regular prisms and cylinders. So we've looked at surface area, which is to do with the area of all the different faces added together. The volume is different, and it's important that we make sure we distinguish between the two. The volume of a solid measures how much space the solid takes up. Okay, and it's measured in cubic units. For example, cubic meters, cubic centimeters, cubic millimeters. That's the way that we measure it. And volume is how much space something takes up. We also need to be familiar with the term capacity and volume. And there's a subtle difference, or there's a difference between the way the things that they're actually measured. So capacity is a measure of how much space is inside a solid, whereas volume is how much space a solid takes up. And usually we'll measure capacity in liters or milliliters. We can also use cubic units like cubic meters, cubic centimeters. And so, for example, if you have a box, the capacity is how much can fit inside the box, whereas the volume of the box is how much space that box takes up. Now, in most cases, we can just assume that they're the same, but if the walls of the box are very thick, obviously we can start to see that the thicker the walls are, the bigger the difference between what fits inside it and how much room it actually takes up. And so that's what the difference between capacity and volume is that we need to take into account. There's also a clear link between capacity units and volume units, and so this is a handy thing to be very familiar with. So we need to say 1 cubic meter is actually 1 kiloliter, which is equal to 1,000 liters. Make sure that we're familiar with that. And 1 cubic centimeter, 1 is equal to 1 milliliter. So if you imagine one of the cubic centimeters square, the little boxes that you get, or the little cubes that you get, 1 milliliter of fluid fits inside them. And so that's the link. 1 cubic meter equals 1 kiloliter, which is 1,000 liters. 1 cubic centimeter equals 1 milliliter. Now, finding the volume of a right cylinder or a right prism is actually very straightforward. Much more straightforward than the surface area, which can get very tedious. So to find the volume of a right prism or cylinder, you find the area of the uniform cross-section. So in this case, these blue triangles, showing that wherever you cut it, it's going to be the same shape. So you find the area of that uniform shape, and then you multiply that with the height, or depending on how it looks, the length, or let's just say it's height. So you multiply the area of the base with this height. V equals AH. The volume, V for volume, equals area of base times height of a prism. Now, we're going to have a look at some examples. And so always keep in mind that once you identify what the cross-section is, let's find the area of this base and where you can cut it, and it's always the same. All you have to do is find that area and then multiply it by the height. So we're going to have a look at some examples and see how we go. First one. So we have this actually octagonal prism, so 1, 2, 3, 4, 5, 6, 7, 8. The thing about it gives us the area of this orange face here, and the area is 312. So in this case, all we have to do is to say V equals 312 times the height, which is 64. And so then we just find what that equals to, and we can work that out. So let me just find that real quick. So after we do this thing, we're going to get, if we multiply 312 by 64, we get 19968 in centimeters. So remember, it's centimeters cubed, cubic centimeters. 19,968 cubic centimeters. We just multiply the area of the base with its height. Okay, so that's the first one that we found. go ahead and go to the next one. Next one along. Here we have a cylinder. Now remember that the way that we work out the area, the cross-section of a cylinder is a circle. Okay, so we need to be able to work out the area of this circle. And you remember that the area of a circle, is equal to pi r squared. Out, so just so that we remember this. Pi r squared. So all we have to do is do pi r squared for the circle here multiplied by 48. So if I do that, so V equals pi times 25 squared, which is a radius, and then we multiply that by the height, which is 48. Now, if we find that out, what it is, equals, we will see what we get. So we get 25 squared and add, multiply that by pi, and that is equal to 94,247.78. And again, well, it doesn't have any units, but let's say the units are centimeters, and so we're going to put cubic centimeters here. Cubic centimeters. So that's what we have, 92,247. We found the area of the top, which is the circle, multiplied by its height. So that's the next one. Next example here we have, this one's a trapezoidal prism. But if we cut it along its length, we always got to get a trapezium, which looks exactly the same. Now, we need to remember the area of a trapezium, and so we'll go ahead and do that. So the area of a trapezium is, take the two parallel sides. So we talk about this bottom side, well, let's call A, and we'll call that B. So the two parallel sides, A plus B over 2. So the average of the two parallel sides multiplied by H, which is, in this case, it's 2.8, which is its height. So the perpendicular height, and you multiply that with the average of the two parallel sides. A plus B over 2 times H. So if we go ahead and do that, let's work out the volume, and all we're going to have to do is work out that area of this trapezium multiplied by its height. So let's do that. So we get V equals, we're going to find the area of the trapezium, 7.7 plus 11.3 divided by 2 times 2.8, which is height. Okay, so that's the area of the trapezium we've worked out. And all we have to do with that is then multiply it by the 5.5, which is the length. Multiplied by 5.5. We work that out. That is equal to, go ahead and find it. 7.7 plus 7.3 divided by 2, multiply that by 2.8, and then you multiply that by 5.5. And that is equal to 146.3. Again, we need to put the units correctly, and say they're centimeters, In this diagram, the lengths are all centimeters, so then this would be centimeters cubic centimeters. That's what we would end up with. 146.3. Alright, so here we have the third example. So we've had a octagonal prism where we're given the area, we've got a cylinder, we've had to find the area, and a trapezoidal prism. Now we have one which is kind of like an L shape. You can't directly find the area of this, but there's a few ways that you could break up the surface at the front to find its area. So we'll go ahead and do that. And so if I can draw a line in to break up the area. Imagine this front. I'm going to draw a line in here. So what's going to happen is I've got this here, which is this square, or very close to a square, and I've got this long, thin rectangle. So I need to work out both of these areas, add it together, and then multiply it by 3.2, which is its depth. So we're going to go ahead and do that. So if I can have a look at this figure, this distance here is going to be this 12.7 minus 7.2, because 7.2 goes from here to here, and 12.7 goes from all the way across, and so that must be the distance that's left. And similarly, I need to find what this distance is, the height of this section. Now the height here is the difference between 19.6 and 11.3, because 11.3 goes from here all the way up to the top here, and so what's left must be 19.6 minus 11.3. So we're going to go ahead and do that and find these measurements. So first up, we need to find 12.7 minus, what do we say, 7.2? That's 5.5. So I can go ahead and write that in, which is, remember, 7.2 is this distance, 12.7, so that one's 5.5. Let's see if I can get what I'm saying. 5.5. Now the other one we had to do was 19.6 minus 11.3. That's 8.3, so that's this distance here. I'll draw that in. 8.3. Alright, so now we know that we have the dimensions for this square, and we have the dimensions for this rectangle. We can add them together, work out the area, and then we know what the depth is. So what I'm actually going to do is I'm going to redraw this shape with the dimensions. So if I do that, we're going to get something along the lines of, excuse the fact that it's very rough, but we'll get the idea. Okay, so that's our rectangle, and then if I put a dotted line in here, that's 5.5. I can type in the dimensions. So that's 5.5 here. Over here, we've got 7.2. Because 5.5 plus 7.2 is 12.7. The height here we found out was 8.3. So that's good. And then we need this dimension, which is 19.6. And there we have it. We've got the two dimensions of each rectangle, 5.5 and 19.6. And then we've got the dimension of this square, which is 7.2 and 8.3. So the area of this figure is equal to 7.2 times 8.3 plus 5.5 times 19.6. So if we find that, we'll be able to work it out. 7.2 times 8.3 plus 5.5 times 19.6 equals 167.56. And again, we need to work out our units, centimeters, cubic centimeters. So I've worked out the area, and so the final step is to work out the volume. Okay, well, V equals 167.56 times the depth, which in this case is 3.2. And so that's the final step. We can work that out, and that is 167 times 56 times 3.2 equals 536.19 cubic centimeters. And I realize that I've made an error. This one here is not actually cubic, this is an area, so it needs to be squared. Okay, this one is the volume, so hence it's a cubic. Alright? Now I think I have one more example to do, but I'm going to leave that one, and I'm going to let you have a look at the example that's in the book of that, and you can copy it off. And so I'd like you to work on the following questions from your book. Exercise 204, 2.04. Do every second question. Okay, so 1 AC, question 2 ACE, etc. Question 3. However many. Do every second part. Take your time, show your working, and give it your best shot. Okay, see you later.